Okay, we're going to solve for three variable system linear equations. And these are the three steps we're going to use. First of all, we want to write the system in three variables as a system in two variables and solve for two variables. Once we find those two variables, we substitute them back into one of the original and get the remaining variable. I think the best way is just to do an example. I have 4 examples I'm going to use, and the first one is this one right here. We have a system of 3 variable equations, and what I want to do is eliminate one of the variables in both equations. So basically what I want to do is eliminate my y. So the first thing I'm going to do is take my third equation here and multiply it by 2. So I'm going to write this equation down, 4x plus 2y plus 3z equals 1. And this one, I'm going to multiply everything by 2. And when I do that, I'm going to get 12x minus 2y plus 8z equals negative 2. And when you solve for this, you're going to get 16x plus 11z equals negative 1. So there's my first equation. Now, so you might want to write it down because we're going to go on the next page. The next one I have, I'm going to multiply or add negative 3 times equation 3 to equation 2. So basically, I'm going to write down equation 2, which is 2x minus 3y plus 5z equals negative 14, and I'm multiplying my equation 3 by negative 3. So I get negative 18x plus 3y minus 12z equals 3. Now when you combine that, again, we're getting rid of the y. So we get negative 16x minus 7z equals negative 11. Now, I have 2 equations with 2 variables, and I'm going to solve for these like you would normally for a system. So I'm going to write these down. I have 16x plus 11c equals negative 1, and negative 16x minus 7c equals negative 11. When you combine this, you're going to get 4z equals negative 12, so z equals negative 3. If z is negative 3, you plug this back into one of these, and you're going to get 16x minus 33 equals negative 1, and we're going to get 16x equals 32, so x is 2. So for our 3 system, we have a 2 and we have negative 3, but we still need to find our y. We eliminated y, so all we're going to do is plug these 2 back into one of our originals equations, and when you substitute, let's use the first one, or let's use the last one. So I'm going to use 6x minus y plus 4z equals negative 1, and I'm going to plug in my x, which was 2, don't know my y, my z was negative 3, equals negative 1, so we're going to get 12 minus y minus 12 equals negative 1, so basically negative y equals negative 1, so y equals 1. So that means our solutions is going to be 2, 1, and negative 3. It's called an ordered triple because that's x, y, and z. Remember, when you do parentheses, that means it's ordered. Okay, let's do another one. We have x plus y plus z equals 3. 4x plus 4y plus 4z equals 7. And 3x minus y plus 2z equals 5. Now what I'm going to do is go ahead and take this top equation and multiply it by negative 4. So I get negative 4x minus 4y minus 4z equals negative 12, and add it to, this is equation 1, this is equation 2, equation 3. Add it to equation 2. I think you can see what's going to happen here. And what happens is all this cancels, and we get 0 equals negative 5. And like we said in the previous video, when you have something that's not true, that means there's no solutions. That basically means these are parallel lines in 3 space. Okay, the next one we have is x plus y plus z equals 4, and x plus y minus z equals 4, and then we have 3x plus 3y plus z equals 12. Now right here I can take this and add these two, because when I add these two I will eliminate my z's. So when I'll write this again, x plus y plus z equals 4, x plus y minus z equals 4. When I add, I get 2x plus 2y equals 8. All right? And then I'm going to do the next equation. I'm going to, maybe I can do it here. I'm going to multiply my second equation by negative 3. Or I can do, let's see, yeah, I'll multiply it by 3. And what I'll get, or actually, since these already subtract, I'm just going to add these two here. So I'll do that here. I get x plus y minus z equals 4, and 3x plus 3y plus z equals 12. When you add this up, you're going to get 4x plus 4y equals 16. Now, I have to solve for x and y, so what I'm going to do is bring this one down. We'll try to do it all on one page here. 4x plus 4y equals 16. Now, when I multiply this one by negative 2, what's going to happen is we're going to get negative 4x minus 4y equals negative 16, and 4x plus 4y equals 16. When you add this up, you're going to get 0 equals 0. And remember, when you have something like that, that means there's infinite solutions, because these lines coincide with one another. So you don't have to finish anything up. We're done. So that's infinite solutions. Okay? And that is all. The next thing we're going to go over is the determinant and Kramer's rule. And you'll have a nice day.